You've probably heard both sides of this argument at some point. Someone tells you evolution is just a theory. Someone else tells you it's as solid as gravity. Both of them are using the word theory like a weapon, and almost nobody stops to ask what scientists actually mean by it. So let's actually answer the question, is evolution real? And if it is, how do we actually know? Start with that word, theory, because it's doing more damage to this conversation than almost anything else. In everyday language, a theory means a guess, a hunch, something you're not sure about. But in science, a theory means something almost the opposite. A scientific theory is an explanation that has been tested repeatedly, that makes accurate predictions, and that has survived every attempt to prove it wrong. Gravity is a theory. Germ theory is a theory. Evolution is a theory in exactly that same sense, which means it's one of the most rigorously tested ideas in the history of human knowledge. So what is the actual claim? Evolution says that populations of living things change over time through genetic variation and natural selection, and that all life on Earth shares common ancestry going back billions of years. That's it. Not, we came from monkeys. Not, everything is random chance. Just, populations change, and the mechanism driving that change is differential survival and reproduction based on genetic differences. Now here's where it gets interesting, because you don't actually have to take this claim on faith. You can watch it happen. In 1988, microbiologist Richard Lenski started an experiment that is still running today, decades later. He took a single strain of E. coli bacteria and split it into 12 separate populations, all growing in identical conditions. Then he just let them evolve. Every single day for over 35 years now, his lab has transferred each population to fresh growth medium and frozen samples of the previous generations for later comparison. What Lenski found is almost too clean to be believable if you didn't know it was real. Over tens of thousands of generations, the bacteria evolved measurably larger cell sizes, faster growth rates, and in one population, a genuinely new ability. Some of the bacteria evolved the capacity to metabolize citrate in the presence of oxygen, something E. coli normally cannot do at all. Lenski's team could trace the exact genetic mutations responsible, generation by generation, because they had frozen samples of the entire lineage sitting in a freezer the whole time. This wasn't a computer simulation. This wasn't inference from old bones. This was evolution, caught in the act, with a paper trail. But maybe you're thinking, sure, bacteria evolve fast. They reproduce every 20 minutes. What about animals we can actually watch on a human timescale? This is where the work of Peter and Rosemary Grant becomes so important. Starting in 1973, the Grants began studying finches on a tiny, remote Galapagos island called Daphne Major. They caught, measured, and tagged nearly every finch on the island year after year, tracking beak size down to fractions of a millimeter across multiple generations. Then, in 1977, a severe drought hit the island. Food became scarce, and the finches that survived were disproportionately the ones with slightly larger, tougher beaks, capable of cracking the hardest remaining seeds. Within a single generation, the average beak size of the surviving population measurably increased. When rains returned and food became abundant again, the selection pressure reversed, and beak sizes shifted back the other way. The Grants had watched natural selection reshape a population in real time, driven by nothing more mysterious than which birds survived long enough to reproduce. That's not ancient history. That's a research team standing on an island with calipers, measuring the same mechanism Darwin proposed in 1859, happening in front of their eyes. Okay, so evolution clearly happens on small scales, in bacteria and in finch beaks. But here's the question that actually makes people uneasy. How do you get from small changes like that to entirely new kinds of animals? How do you get from fish to creatures that walk on land? This is where the fossil record earns its reputation as evolution's most dramatic witness. For a long time, one of the biggest gaps skeptics pointed to was the transition between fish and four-limbed land animals. Then, in 2004, paleontologist Neil Shubin and his team went looking for exactly that missing piece, and they didn't search randomly. Based on the age of rock layers where earlier fish and early land vertebrate fossils had been found, Shubin's team predicted that if a transitional form existed, its fossils would be sitting in rock of a specific age in a specific kind of ancient river environment. They picked Ellesmere Island in the Canadian Arctic because the geology matched their prediction almost exactly. They found what they were looking for. The fossil, later named Tiktaalik, had fish scales and gills, but it also had a flattened head, a mobile neck, and most strikingly, limb bones inside its fins, including a wrist joint, arranged almost exactly the way you'd expect an intermediate step between fish fins and a land animal's leg to look. This wasn't a lucky accident, it was a prediction made in advance based on evolutionary theory and then confirmed by digging in exactly the right place. That's the part that should genuinely impress you. A good scientific theory doesn't just explain things after the fact. It tells you where to look for evidence you haven't found yet. Evolutionary theory told scientists exactly where, geologically, a fish-to-land transitional fossil should exist, and it was right. Now, here's where things get honest, because good science requires honesty about its own limits. Evolutionary biologists absolutely do argue with each other. They argue about the pace of change, whether evolution moves in slow, steady steps or in sudden bursts, followed by long periods of stability. They argue about exactly how certain structures evolved, or which specific ancestor connects to which specific descendant. They argue about the relative importance of different mechanisms, like genetic drift versus natural selection. But none of those arguments are about whether evolution happened. They're arguments about the details of how it happened, the way physicists argue about the exact behavior of subatomic particles without anyone seriously proposing that physics itself is fake. The core mechanism, genetic variation plus differential survival, producing change in populations over time, isn't the part under debate. That part has independent support from genetics, from the fossil record, from direct observation in labs and in the wild, and from comparative anatomy, all pointing in the same direction, all converging on the same conclusion from completely different angles. That convergence is actually the strongest argument of all. It's not just one line of evidence. Geneticists sequencing DNA find the same evolutionary relationships that paleontologists find in the fossil record, which match the same relationships anatomists find by comparing skeletons, which match the patterns biogeographers find by mapping where species live around the world. 4 completely different fields, using completely different tools, arriving at the same family tree of life independently. So where does that leave the actual question, is evolution really true? The honest answer is that true might even undersell it. Evolution isn't a belief you're being asked to accept on faith. It's a mechanism you can watch happen in a bacterial culture over a few years, in a finch population over a single drought. And it's a mechanism that successfully predicted exactly where to dig up a 375-million-year-old fossil showing fins turning into limbs. The disagreement you hear about evolution isn't really a scientific disagreement at all, it's a values disagreement, wearing a lab coat. And that's a completely different conversation than the one about whether the evidence holds up. The evidence holds up. It's held up for over a century and a half, under more scrutiny than almost any other idea humans have ever tested. So the next time someone tells you evolution is just a theory, you can tell them they're right. And that's exactly the problem with how they're using that word. It's a theory in the same sense gravity is a theory. Tested, predictive, and still standing after everyone who's ever tried to knock it down. The more we learn about the past, the better we understand ourselves. If this video sparked your curiosity, don't forget to like, subscribe, and follow Phoenix Primeval for more fascinating stories from history, science, and human evolution. Thanks for watching.